In algebra class today, we're taking a look at lesson 43, simplifying rational expressions. Now, the goal in simplifying rational expressions is going to be played out by completing the lesson practice problems. If I were you, I'd pause this video right now, make sure you've watched the first instructional video that's been posted on our classroom page, and then come watch this after you've done that. You've got some background knowledge that'll play out as I solve these practice problems there at the end of each lesson. See, each one of these refers to what we learn in each of the different examples. For example, in example 1, it says determine when an expression is undefined. In all rational expressions, you've got some type of variable in the numerator and the denominator. And we know that if there's ever a 0 in the denominator, that overall expression is undefined because 0 doesn't exist in that denominator place. So if there's ever a variable there, well, what if that variable turns that denominator into a 0? You've got to determine when that actually cannot happen or cannot be. There's a pattern that's going to show up when you see some type of multiplication like this, and also when there's some type of addition or subtraction like this, on how you're going to go about solving for what this value actually cannot equal, because then it would be undefined. In example 2 then, in these 3 problems, we're going to learn how to simplify these rational expressions by using a previous skill that we've learned, finding greatest common factor, or factorization. We're going to learn to factorize the numerator and the denominator, pick out what is similar in each, and then actually use that to simplify the expression and cancel, where we can find something that is the same in both the numerator and denominator. Let's get into it. In letters A, B, and C, it says find where this expression is undefined. So what I'm focusing on here is what's actually in the denominator. And in this example, you've got 16x minus 7 divided by 5x. What can x not equal to make this denominator overall 0? Well, in order to do this, what you want to actually do is write the expression so that it actually equals 0. So you say 5x is my denominator, I'm going to set that equal to 0, and I'm going to try and solve for x. If I would solve for x, that means I'm trying to get x by itself, or do the opposite operation so that x is by itself. I would divide by 5 here and divide by 5, x equals 0 over 5, or x equals 0. X can equal 0, and you're going to notice why here, because if x equals 0, it would be 5 times 0. Anything times 0 is going to be 0, therefore 0 would be in the denominator. So x cannot equal 0, or it would be undefined at that specific value. For letter B, we've got 1 plus 3x divided by x plus 8. Now, the first one we had multiplication and x could not equal 0. Here we've got addition. Let's see if there's a difference between these two. First thing I'm going to do is take that overall denominator, x plus 8, which is right here, and I'm going to set it equal to 0. I'm going to make it equal to 0 because that's the equation that I want to solve to say what can it not be actually as a 0. So I set x plus 8 equals 0, and I'm going to solve for x, get x by itself. It says plus 8, so I would do the opposite, which is subtract 8. If I subtract 8 from one side, I subtract 8 from the other side, my new expression would look like this. X equals negative 8. Because if x equals negative 8 plus 8 is actually 0. You got it. So x cannot equal negative 8. It would be undefined at that specific value. So in addition to subtraction, it's actually equal to a number. In multiplication, it cannot equal 0 because anything multiplied by 0 is 0. Here, you've got both of those principles playing out. You've got multiplication and subtraction. So let's take the entire thing and follow the same steps. I'm going to say 6x minus 42. I'm going to set it equal to 0. So equals 0. Now I'm solving for x again by using my opposite operation. I would add 42 to this side, add 42 to this side. Rewrite the expression 6x equals 42. Divide by 6, divide by 6. X equals, well, what's 42 divided by 6? 6 times 6 is 36. 6 times 7 is 42. So x equals 7. If x would equal 7 here, 7 times 6 would be 42. 42 minus 42 would be 0. So x cannot equal 7. I'm finding where it's undefined, so I'm saying that it cannot equal those specific values. The first thing I do is I set it equal to 0, solve for what that variable would be if it was equal to 0. But now I've changed it to say I cannot have it equal that because it would be undefined in that location. Now for letters D, E, and F. Now this refers to example 2 in your textbook on page 271, in which it's giving you a set of steps to follow. The first step is determine undefined values. So the first thing you do is you see one of these, and you say, well, what can x not equal from the get-go? Anytime it's multiplication, it's really easy. For this first one, x can equal 0. Here, x can equal 0. And here, x can equal 0. Anytime there's multiplication involved, that's one of the values that x cannot be. We might have to come back to that at the end. Next thing it tells you to do is find the greatest common factor, the GCF, of the numerator, and then it's find the GCF of the denominator. So you're finding this both times, and we know how to do this because we've practiced factorization over and over and over. In the top here, here's where I would write 7 times x minus 27. 27 is not a prime number, so I'm thinking prime factorization. How can I break that down? 27 would be 3 times 9, and 3 times 9, or 9 would be 3 times 3, right? 3 times 3 is 9 times 3 is 27. Here's what I have as my numerator, and it's factored out. Are there any things that I can simplify on both sides of that expression that would break that down anymore? Doesn't look like it. In the denominator, guess what? I've got 5 and x. There's nothing else that I can do in reference to finding the greatest common factor. So this is kind of a trick question. There's nothing here to simplify. This is completely simplified. The only thing I would add to this, I would say x cannot equal 0. Okay? Now in letter E, we're going to do the same thing. Find the greatest common factor of the numerator and the denominator, and then we'll fill in what x cannot equal. Here you've got 3x squared minus 3x. Here's how I would write that. 3 times x minus 3 times x, right? That's my numerator. Now what's the same in terms of finding the greatest common factor? I'll circle what's the same on both sides of that subtraction sign. I've got a 3x on both sides. So greatest common factor says pull that out. Give me a new answer with that completely pulled out. We'll use the space over here. 3x is going to be removed, and whatever wasn't circled is going to stay into each part of this expression. So I have x here in this first term, minus, if I've circled both things, it's just going to be 1 in that second term. Okay? Now let's fill in the denominator. I've got 9x squared plus 15x. 9 would be 3 times 3. X squared would be x times x. Plus 15, which is 3 times 5. Times x. Again, do the same thing that you did here. Circle what's the same. I've got a 3 on both sides of that plus sign. I've got an x on both sides of that plus sign. Looks like I can factor out the x. Remember, factoring, greatest common factor is the opposite of the distributive property. So I've worked backwards to say 3x was not distributive but pulled out, and whatever's left is going to give me this overall answer. So 3x times 3x gives me 9x squared. That checks out. How about 3x times what's over here? 15. So 3 times 5 is 15, so I'm going to have plus 5, because that wasn't circled, left on this side. Now here's the part of the expression that I need to simplify still. What do if I've got something that is the same in the numerator as I do in the denominator? Well, those things cancel each other. Now my finalized expression then is going to be just this. Now it's, as we're learning, simplified because I've eliminated a factor that was the same in both the numerator and the denominator by finding that greatest common factor and then canceling those things out. Now, originally I told you that x could not equal 0 because we had multiplication here. That's true, but now in this case I've got 3x plus 5. I would have to find that again to figure out what that's going to be. To do that, let's go back to what we learned in A, B, and C. We take the denominator, we set it equal to 0, and we solve. Minus 5, 3x equals negative 5, divide by 3, x cannot equal negative 5/3. So both of those would be answers that would go in correspondence with what we have as a simplified expression. 1, because this was the initial expression that we looked at and said this is where it's undefined. 2, because at the end we've now simplified the expression to include another answer for the variable where it would be undefined. The last one that we're going to look at today is letter F. We've got 4x plus 28 divided by 3x squared plus 21x. Find the greatest common factor of each one. We already know that x cannot equal 0 because there's multiplication happening in the denominator, so we would set this up to factor it out. 2 times x is my 4x factorization. 28 would be 2 and 14. 14 would be 2 and 7. 2 times 2 is 4, times 7 is 28. That checks out. Now, is there anything I can factor on both sides of letter F? I've got a 2 here, and I've got a 2 here, I've got a 2 here, and I've got a 2 here. Looks like I can pull out a 4 in that overall factorization. What's left inside would be x plus 7 in the numerator. So now my numerator has been factorized. The denominator then is 3x squared, which would be 3 times x plus 21x squared, which would be 3 times 7 times x. And now I would again factor out what's the same. 3 and 3 on both sides of that plus sign, x and x. So 3x gets eliminated. Still remaining inside the parenthesis would be an x plus 7. Notice the difference this time compared to what we did here. When we factored here, the things that were pulled out, the 3x, those were eliminated because they were the common portions. Here, what's remaining inside, what's not the greatest common factor, happens to be the same, but we do the same thing. If I've got something that's the same in the numerator as in the denominator, guess what? Those two items would cancel. My overall answer here would be 4 over 3x. Therefore, still, x cannot equal 0 is my final answer in that expression. Again, the overall rules for solving problems such as this is to find where something is undefined by setting that denominator equal to 0, finding where x cannot equal 0. Then, when you're getting into the factorization, you find the greatest common factor of the numerator and of the denominator. If you have to, come back and double check at the end if there's something else you need to say that x cannot equal. That's it for lesson 43. If you have any questions, please tune in later or get a hold of Mr. Shane. God's blessings on your homework assignment.